Hello, my name is Eric. I am part of Water School and Media Lab. Today the old lights were taken down and will go to be recycled at the scrapyard. This is good because the old lights wasted too much energy. The new lights will be solar powered. We also interviewed Joe, who is a general manager for Sanchez Construction. He explained what's happening and gave us a tour.
I'm Joe with Sanchez Construction. We're the site contractor here at Waters Elementary. Right now, as you can see, we're taking down all the site lighting. The status of the project so far is that we're at rough elevation for all the earthwork, if you wanted to go inside there. Now what we've done so far is we've taken, you can walk in here a little bit. Right now is we're at site subgrade, so all the earthwork is pretty much done. As far as digging any deeper, not much. This is about as deep as we're going to dig on the site. And if you walk in a little bit, this first area is a rectangle in shape. That's going to be the multi-purpose field. So that's going to be, and it's going to have quite a bit of porous stone beneath it. So it's going to hold a lot of rainwater underneath the playing field. And this is just the rough elevation or the rough cut, really right in front of us here, and that's where the playing field will be. Did you want to walk a little further in? So right now I'm standing pretty much in the middle of the field right now, okay? And then to our east, along Campbell here, are going to be two large bioswales. So the idea here is that a lot of rainwater will be stored beneath the playing field, and when that water hits its capacity, it's going to percolate into these bioswales that are positioned parallel to and along Campbell. So there's going to be quite a bit of detention in here. And then as this overflows, and it's all beneath the playing field, so it'll maintain structurally, meaning that you can have water underneath this playing field and still it's going to be a firm field. It will never lose its elevation or become depressed. So it's structural stone that's natural, coming from a limestone quarry, and that's going to hold water here, and then as that fills, it's going to go into the bioswales. So like I said, these are the rough cuts for the bioswales, and I'm standing in the middle of the play field. Now tomorrow we'll start the storm sewer drainage. All the pipe work will start tomorrow. So we'll start getting deliveries of the concrete structures and piping and all that this afternoon, and then there'll be a storm sewer crew, and that's going to start all the drainage systems that for the most part are going to be contained on the site. And that's what makes this project so much different than what we're typically used to, is that very little water is going into the City of Chicago storm sewers. There is an outlet, and it's minimal, and it's just for the 100-year storm. And so for the most part, this is an interesting project. Certainly from our standpoint, it's a lot of fun to do. So far, and it's right on schedule, and everything's going exactly according to plan. That's pretty much it. Well, we're standing right pretty much in the middle of our northernmost bioswale. There are two bioswales here at Waters Elementary. A bioswale, what does it do? A bioswale is pretty much a hole in the ground here, and it's going to be an obvious hole. When the site's complete, for the most part, the surface drainage of this property is going to come in the direction of this bioswale and the other bioswale. And if you could just picture a big depression in the ground here, just pretty much how it's roughly dug now. Needless to say, when it's complete, it's going to look a lot prettier than it looks right now. But the entire site will drain to these bioswales, not just surface drainage, but also underground piping. So all the pavements and installations that happen on all sides of this school will ultimately terminate in these bioswales. These bioswales are connected to the city storm sewer, but the volume of water held by these bioswales will greatly reduce the amount of runoff that does get to the city storm system. And if you're familiar with the City of Chicago and its storm sewer system, it's already taxed and at capacity. So the less water we send to the city storm sewer systems, the better. Better for the city, better for the environment, better for everybody. And this is a picture-perfect model of a project for on-site stormwater retention.